Question number 4. An apparatus is used to verify a gas law. The glass jar contains a fixed volume of air. Measurements can be taken using the thermometer and the pressure gauge. Okay, this is 4 marks, very short question. You would need only something like 5 minutes, not more than that. So pressure gauge, thermometer, the glass jar, everything is given here. The apparatus is cooled in a freezer and then placed in a water bath, so temperature of the gas increases slowly. Okay, the pressure and temperature of the gas are recorded. So what are you going to do? You are going to keep this is cooled in a freezer, then placed in a water bath. What is the water bath? It increases the temperature. Okay, now, and as you increase the temperature, you are going to find out what's happening to the pressure. The volume of the gas is not going to change. Okay, now by now you would have thought of what could happen, but anyway, since it's a data analysis question, let me assume that you don't have any idea of thermal physics. Okay, the graph shows the data recorded. Now what do you see in the graph here? You see that the pressure and temperature are being related like this, and somewhere the graph is hanging here. It's not starting from the origin. Why? Because they started the temperature only at 250 Kelvin, right? You cannot bring it back to, you can bring, but we don't have that kind of freezers, defreezers. Maybe the experimentalist does not have a deep freezer wherein he can bring in the temperature to 0 degree Kelvin. Okay, now let us see whether I can pull this back, this line. When I pull this back, I observe it goes to 0. Okay, now T versus pressure is being shown over here. And identify the fundamental SI unit for the gradient of the pressure temperature graph. Pressure temperature graph. This is your gradient. This is your gradient, right? What does pressure temperature graph gradient tells you? This is delta P. This is your delta T. So therefore, P by T should be a slope. Gradient should be delta P divided by delta T. Is only asking you the SI unit for the gradient, nothing else. Okay, do not worry what kind of gas, what equation, nothing. No, you need not worry about anything here. Now therefore delta P, what is P here? P is nothing but force by area, and delta T should be measured as temperature. Now what is the unit for force? Kg meter per second square, m into a, divided by area is meter square, divided by Kelvin, temperature in Kelvin. So if I write this becomes this meter and this square goes away. I'll write this as kg per meter per second square per Kelvin. That's it. This gives you 1 mark. Very easy, right? The experiment is repeated for a different gas in the gas jar, and pressure for both experiments is lower. Pressure is lower. Both the gases can be considered to be ideal. Okay. If you know what is ideal gas, then fine, we can know that PV is equal to nRT. This equation can be applied. Using the axis provided in A, draw the expected graph for the second experiment. It says pressure is lower. So what we need to do is, let me go here. If pressure has to be lower, let me take up one more point. Okay. Now there are two things that has been given here. One is ideal gas. Okay. So like this, if this is an ideal gas, it starts from the origin. If you extrapolate this backwards, it starts from the origin. In a similar way, if I draw a line from the origin here, but I need to start only from here. Okay, because it starts at 250 Kelvin. So what I can do is I can write like this. Okay, so therefore this will be one more graph. This will be one more graph which tells you that the pressures are lower, temperatures are increasing with the pressure. Okay, like the experiment that he has done. But this is for a different gas. Okay, we have done this also. So now this graph is done. Explain the shape and intercept of the graph. Shape. What is the shape? Shape tells you first one. This is for how many marks? This is for 2 marks. So you can say that the first one you can say that is pressure is proportional to temperature, right? Because temperature is in Kelvin, we can mention this. The second one you say that intercept equal to 0, or the line passes through the origin. Line passes through the origin. Similar to what you have seen in the previous one, here also it passes through the origin. And thirdly, one more point if you want, you can put. You need only 2 points, but anyway, he is asking you about the shape of the curve. You can say the slope should be greater than 0, right? What does it mean? Why do you want to put this here? Because you are showing that P is proportional to T. Okay, suppose if you draw a graph like this, okay, here also P is proportional to T, but unfortunately the slope is negative here. This cannot happen. Okay, because when you increase the temperature, pressure is seen to be increasing. So therefore this is the right graph. Okay, so thus I think we have finished all the questions in this. It's a very short question. Let us see you tomorrow once again. Thank you.